morning, sir, ma'am, and my dear friends. My name is Aman Yadav. I am pursuing BTech third year in civil engineering from Khwaja Muhyiddin Chishti Language University in Lucknow. Today I am here to present my seminar on the topic of desalination technologies for freshwater supply under the guidance of Engineer Costless Mursa sir. Introductions, desalination processes, using renewable energy, desalination barriers, future recommendations, summary and conclusions, references. Introductions. According to a recent report by World Health Organization, WHO, only 71% of the global population, 5.2 billion people, uses safe drinking water while remaining lack even basic drinking water services. Can we drink saline water? Water that is saline contains significant amounts referred to as concentrations of dissolved salts, the most common being the salt sodium chloride NaCl. Second, small quantities are not harmful, but it is counterproductive. It just makes you more thirsty. Third, eventually it can be dangerous, ultimately producing fatal seizures, gut arrhythmias, and kidney failure. Fourth, total dissolved solids TDS represent the total concentration of dissolved elements in water. TDS is less than 300 mg per liter is excellent, 300 to 600 mg per liter is good, and 1200 mg per liter is undesirable for humans. Natural desalination plants. Groundwater to evaporate to condensations to precipitations in the form of rain and snow to surface runoff to groundwater. Desalination is a process that extracts salts and mineral components from salt water to render it suitable for drinking, irrigations, or industrial uses. Secondly, currently 59% seawater, 23% brackish water, 7% rivers, 5% wastewater, and 6% other sources are used for desalinations. Third, currently approximately 1% of world's population is dependent on desalinated water to meet daily needs, but United Nations Human Rights expect that 14% of the world population will encounter water scarcity by 2025. Desalination processes. Separation processes is divided into two types: thermal, membrane. Thermal is divided into four types: multi-stage flash, MSF, multiple effect distillations, MAD, vapor compression mechanical and vapor compressions thermal, MVC and DVC, humidification, dehumidification, SDH. Membrane is divided into two types: reverse osmosis and electrodialysis. Thermal desalination processes. These processes imitates the nature's desalination process, as they comprise evaporations, condensations via different schemes to produce fresh water. Membrane-based desalination processes. First, reverse osmosis is the most widely used method for desalinations that uses a semi-permeable membrane which resists salt passes. Second, in electrodialysis ED system, a direct current is passed through the water which drives the ions, not the water, through membranes to electrode of opposite charges. Desalination processes using renewable energy. Sources of renewable energy is divided into four types: geothermal energy, wind energy, solar energy, others. Solar power desalination plants. First, indirect solar desalination systems. Indirectly, as an energy sources, solar energy is converted to electrical energy using PV arrays and utilized to power desalination processes. Direct solar desalination system directly converts solar energy to heat and use it to power the desalination processes. Solar desalination. Desalination using solar energy is divided into two types: direct solar desalinations, indirect solar desalination, yani photovoltaics. Direct solar desalination is divided into many types: solar steel, solar chimney, solar pond, solar HDH desalination, solar concentrator. Indirect solar desalination photovoltaic is divided into many types: reverse osmosis, MED, MSF, TBC, ED. Solar steel. Basic elements in a solar steel: first, incoming radiations energy; second, water vapor productions from brine; third, condensations of water vapor condensate; fourth, collection of condensate. Major desalinations plant in India. First, Minjur Seawater Desalination Plant, 100 mld million liters a day, in Tamil Nadu, inaugurated in 2010. Second, Nemelli Seawater Desalination Plant, 100 mld in Tamil Nadu, inaugurated in 2013. Third, in partnership with Gujarat government, a group of Singaporean and Japanese companies such as Hyflux, Itochu, and Hitachi are developing Asia's largest desalination plant of 336 mld capacity with an investment of 4,000 crore in Dahej, Gujarat. Desalination barriers. First, cost. Desalination processes involves a lot of cost in terms of plant constructions, fuels, maintenance, etc. Second, energy consumptions. Water desalination consumes a huge amount of energy that is obtained by burning fuel or using energy or nuclear energy that thus reach CO2 levels or complication of nuclear leakage. Desalination's barrier. Third, environmental impact. Rejection of brine back into sea while delivering into the sea possesses large amount of dissolved salts in it, and this has a negative effect on the marine life. Second, burning of fossil fuels to obtain energy also poses a threat. Scaling. What is scaling? The accumulation of salt particles on the desalination plant components. How to minimize scalings? Adding of chemicals like polyphosphate. Conclusions and future scopes. Water being necessary for consumptions, household uses, industry productions, and agriculture, its demand will rise with economic and population growth. Desalination of seawater and brackish water is accepted as an alternative source to fulfill growing water demand. The benefits of desalinations are straightforward: more water. The drawback, unfortunately, is the cost of environmental impact. Fourth, find alternatives to energy used for the desalination processes through the use of renewable energy such as solar or wind power. Fifth, technologies continues to produce new methods and better solutions to the issues that exist today. There would be a whole new water resource for more and more countries that are facing drought, competition for water and overpopulations. Thank you.